I welcome you all back to this session on analog electronics. In today's session, we are going to discuss about working of PN junction diodes. So in the last class, we have discussed about diodes and where it has been used. So the same applications again I am mentioning here. It is used normally in an adapter, a very everyday application which we are holding always. And different applications are there: rectifiers, voltage multipliers, clippers, clampers, protection circuit, in logic gates, light emission, light detection, AM envelope detector, frequency mixer, and so on. Now in this lecture, we are going to discuss the principle of PN junction diode and its working. It works in two conditions. One is forward bias condition, another one is reverse bias condition. When the PN junction is not biased, it will be in zero biased condition. So PN junction normally will be in zero bias condition. If we want to make it to do some task, we have to give some bias, that is our external voltage above the threshold voltage. So based on that, we have two biases, forward bias and reverse bias. First is zero bias condition. In zero bias condition, the depletion region acts as a carrier. When P and N junctions, N materials are brought together, a PN junction will be formed, and this PN junction has neutral, that is positive and negative electrons and holes will be even, and so no movement of electrons will be there in the depletion region. When the depletion region enlarges, the movement of electrons and holes will be completely blocked. So no movement of majority carriers will be there towards the other junctions. Because of this, no flow of electrons will be there, which leads to zero efficiency of a diode. So in order to, this is how a zero bias condition looks. See here, a P-type and N-type materials are there. When it is being joined, a depletion region is formed wherein the majority means holes and electrons will accumulate at this point. They are neutral, and so no movement of electrons will be further there between the junction. So in order to overcome this, we go for biasing. Biasing is, as I said, giving some external voltage. So first kind of biasing is forward bias condition. In a forward bias condition, a P-type of the semiconductor is connected to the positive end and N-type is connected to the negative end of the battery. That is, in a P-type materials, holes will be the majority carriers, and so P-type is connected to the positive end. And in an N-type, electrons will be the majority carriers, and that is connected to the negative end of the battery. And always the biasing voltage should be greater than the forward voltage of the diode. Then only the bias, it starts to conduct. Now coming to forward bias PN junction. Let us see how it works with a small animated video. So this is forward bias. That is, the positive is connected to the P terminal and the negative is connected to the N terminal. When biasing is given, so see here a reverse thing will be created. So what happens is, this is positive and this is positive, so the charges starts to repel and so it moves towards the junction. Here also the electrons will move towards this junction, and because of this, now the depletion region diminishes. Once, if the depletion region is a region because of which no flow of electrons is there, so when a biasing is being given, the depletion region diminishes. When it diminishes, obviously the flow of electrons and the holes will be there across the junction, which leads to the flow of current. So this is how a PN junction works in forward bias condition. So initially no bias was there, so depletion region is there. Now when I give a positive to the positive and negative to negative, the depletion region diminishes, and now see the flow of electrons and holes is taking place in a quick manner. So flow of current also will be there. Next is reverse bias condition. In reverse bias condition, the N-type of the semiconductor is connected to the positive end and P-type is connected to the negative end of the battery. So at this, as we said, diode is unidirectional. It do not conduct in the opposite direction. No current will be flow until the electric field is high as the diode breaks down. So till it reaches a reverse saturation current, no flow will be there. So this is how a diode is connected in reverse bias condition. So see here, the negative terminal, positive terminal is connected to the N type and the negative terminal is connected to the P type. So at this point, what happens is, see, this is negative and this is positive. So opposite poles attract each other, and so the holes from the positive will be, means P type will be moving towards this side, and so the depletion region enlarges in the case of reverse bias condition. So in reverse bias, normally flow of current will not be there initially until and unless a breakdown takes place. So forward bias is the bias which is commonly used for a PN junction diode. And coming to the VI characteristics. So in VI characteristics is voltage current characteristics. So what happens in the case of forward bias is I am connecting this positive to the positive, and so the depletion region diminishes. So till it reaches the threshold voltage, what happens? It will be maintaining 0, and once if it reaches the threshold voltage, the current starts to increase. So when the bias voltage exceeds the threshold voltage, current will increase in the case of forward bias. In the case of reverse bias, how it works? In the case of reverse bias, see, when I give a negative to this P type and positive to this N type, the depletion region enlarges and no flow of current will be there. When it reaches the reverse saturation point, all of a sudden it breaks and suddenly an increase in current flow will be there in the case of reverse bias. Normally reverse bias is not preferred for a PN junction diode. PN junction is always used in forward bias condition. Now when we are speaking about this diode and currents, we have to know two terms. One is drift current and another one is diffusion current. See, diffusion current is one when there is no biasing. When there is no biasing, when a P-type and N-type materials are connected together, the movement of electrons and holes will be there. This leads to diffusion current. But when a biasing is given, the depletion region gets eliminated and then it diminishes and then flow of current will be there. This is known as drift current, that is with biasing. Diffusion current is without biasing, just a diffusion due to the concentration of the electrons and flows in the holes in the P-type and N-type materials. Flow of current will be there. So that is known as diffusion current. Now coming to the assessment, just think and answer. What is meant by biasing? And another one is threshold voltage for silicon, as well as you should know for germanium too. And thank you for watching. Thank you.